Hello, welcome to this vlog where I 3D print an FTC robot. As an FRC veteran, I was initially inspired by legendary Team 2910's robots from the seasons of 2023 and 2025, where they used the same telescoping arm structure. After I got demoted to work on FTC, I found this really cool linear actuator from OFFSET Robotics. As you can see here, I actually made some upgrades to the design. So they didn't really have this winch drum to secure the ropes. And what I did is that I used this planetary gearbox plus a very weak Neo 550 motor. Since our school's digital fabrication lab is closed for summer break, I decided to 3D print this whole mechanism. Okay, I just need one more push or pull. Oh, yo, that's insane. Okay. What I can do is give you a quick demo of how the cascading of this elevator works. So, as you probably can't see, but I actually applied some, like very thin string right over here, and you can see here's a blue string. Maybe you can see it, and here you can see the cascading motion. So the simple idea is basically the string is attached to this end of L1 and the very bottom of L3, and of course it goes through L2, but it doesn't get secured onto L2. So the idea is that the string makes sure that the distance, of course the distance covered has to be same, but basically what the L2 does is the L2 gives a little push on the string, so that what's initially hidden inside of L2, between L2 and L3, gets squeezed out and goes to the surface of L2. So you can kind of see how it telescopes. You never get tired of it.
I see this life like a swinging vine, swing my heart across the line, and my face is flashing signs. Seek it out and ye shall find. Old, but I'm not that old. Young, but I'm not that bold. And I don't think the world is sold. I'm just doing what we're told. I feel something so right, doing the wrong thing. And I feel something so wrong, doing the right thing. I couldn't lie, couldn't lie, couldn't lie. Everything that kills me makes me feel like I've been losing sleep, dreaming about the things that we could be. But baby, I've been praying hard. Said no more counting dollars, we'll be counting stars. Lately, I've been losing sleep, dreaming about the things that we could be. But baby,
Okay, now we have our third stage assembled, as well as the bulk of our second stage. And now what we're gonna do is merge them. So, just like that. Oh, wrong direction. Yeah, just like that. And the thing with this tube is that it doesn't have a hard limit until you put on the rope to limit the length of extension and retraction. So it's actually going to go all the way out, just like that.
I feel your love and I feel it burn down this river every turn. Hope is our four-letter word. Make that money, watch it burn. Old, but I'm not that old. Young, but I'm not that bold. I don't think the world is sold. I'm just doing what we're told. And I feel something so wrong. We're doing the right thing. I could lie, couldn't lie, couldn't lie. Everything that kills me makes me feel alive. Lately I've been losing sleep, dreaming about the things that we could be. But baby, I've been praying hard. Said no more counting dollars, we'll be counting stars. Lately I've been losing sleep, dreaming about the things that we could be. But baby, I've been praying hard. Said no more counting dollars, we'll be counting stars.
Okay, so now I'm done with the first version, or the first prototype of this FTC linear actuator. So a few details, or a few of my tricks. Well, first of all, as I said, I reversed the nuts and bolts, because it's easier for me to install. And I used the same type of rope for driving the linear actuators, which is actually the same as the FTC teams. And over here we have a Neo brushless motor and a Versa planetary, I think it's is it a Versa? But a planetary gearbox. And over here you can also see I have some winch drums, but they're not working as well as I hoped them to be, so apparently I'm going to have to change that for version 2. And here's a little quick demonstration. Right, so it probably took me over a minute to show how this actuator extends and retracts, but the Neo 550 over here has a free speed of, well, over 10,000 RPM, so, well, of course, after you add the gearbox and the friction inside here, it's going to be slower, but apparently it's going to be much faster than my hand. So basically what I'm going to do next is that I'm going to use this FRC motor, but also the weakest FRC motor, to power this pretty nice FTC design and do a few tests, such as durability tests, precision tests, etc. Okay, so now the experiment environment is set up, and as you can see I have basically the FRC electrical bundle powering an FTC gadget. It's basically an overkill, but I'm just reviewing some of the components. We have the main breaker, the power distribution hub, actually the power distribution panel from CTRE. We have the robo wheel, which is like the main controller. And we have our battery here, and the motor right here. Yeah, this is not the most stable, not the cleanest environment I've built, but it's just for rapid prototyping. So over here I have a joystick controller. Basically for the first experiment, or maybe for the first test, I just wanted to see how the motor drives and whether the ropes are falling into the troughs that I designed specifically for them, and whether there are any hardware issues, like immediate hardware issues. So you can see how it goes. So, oh yeah, forgot to enable. And by the way, I've logged the encoder information over here. So you know what? As I said earlier, this is an overkill. I think this is absolutely on point, because literally the noise created by the planetary gearbox's backlash is even louder than the parts moving, than the linear actuators sliding. Like, hear it out. Oh, and by the way, I'm testing it in this horizontal configuration because I didn't have enough time to build a holder for this gearbox plus motor. You know, this is a very fast 3D printed board, so apparently if I just hold it up like that, it's going to crack very soon. So you can also see I tried to use the battery to hold it, which is very dangerous, so try not to do it. But that's that, and we'll do some later more advanced tests very soon. Alright guys, so here comes our first serious test. So over here I have coded up, a code that commands the robot to basically swing back and forth between two position set points autonomously, and I will shift commands, it will shift commands autonomously every second. So we're going to run that. I'm going to count to 100 times, and I'm also logging the data using data log manager, which later we can export to a CSV file and check out the details. So, and now I'm going to just let it run by itself. Okay, well I can't wait. Let's do this. Okay, so now it is time that we investigate the logs from yesterday. And you can see the wave pattern is quite smooth and quite, pretty uniform. So that gives a good sign. It shows that it basically passed the stress test. And if we want to be a little bit more scientific, and this is also a very, very clean, very uniform curve. So you have to look at this axis over here, so that's 0 for velocity, and it makes sense because this is basically where there is no motion, because it's almost reached the set point. So overall it seems like it has passed the stress test, and not a lot of mechanical wear in the 100 trials, so it looks pretty good. And now you may ask, how justified is this design? Well, overall, I would say OFFSET Robotics did a pretty good job at the lightning. I mean, it's a very clean, it's basically an isometric pattern and pretty standard. And what's nice about it is that basically you know that there are bearings on the internal, so you don't want the bearings to intersect with the lightnings, with the isometric patterns. So they did a pretty good job avoiding that contact, which would cause the bearings to fall off. So that's pretty good. But what I could do later is that we could actually try to run topology optimization to see how we might lighten this design, these extrusions in different ways. But this is a very good starting point. And as for the drum winch, which I designed myself, I would say it would be a passing rate. It would get a passing rate because, well, I would say mostly the ropes did fall into the tracks, but sometimes they are offset by one revolution. So basically, maybe it's one step to the left, but at least it's in the trough, so it would definitely decrease the amount of variance in the retraction length. So overall, this design is a passing grade for me. And in the next version, apparently I have to optimize this winch drum, make a few more guides, and also lighten and optimize my design on the motor holder. But overall, this is a very justified design, and I apparently recommend it. And I actually made another design inspired by this extrusion that is fit for FRC competitions. But I haven't tested it yet, but I look forward to it.